Hello, welcome back to CMSC398L. And for this week, we'll be going over C++ standard library and also some basic data structures. And starting this week, we'll have a pre-recorded video and also we'll teach some problems in class. So mainly the class will be focused on problem solving, and then the pre-recorded video will be focusing on the techniques or the algorithms, or maybe this week we are talking about some C++ like standard library. So yeah, and um, for this video, it might be a little bit long because like it is hard to like cover all the C++ standard libraries like just with maybe 10 minutes. So yeah, so if you already know C++ or something like that, you can just go over my slides or maybe just um, just ignore this video. But if you want to learn about like C++ standard library, then you can like listen to me teaching in this video, and I'll upload this video to YouTube. Yeah, so let's start. So what is C++ standard library? So it is actually just the library that included in C++ that you can use. And then we will have to add some lines before we use the standard libraries. So first, if you look at a C++ code, then you will see like these lines included at the beginning. The first thing is include bits std c++.h, and the second is using namespace std. But what do they actually do? So for bits stdc++.h, it is actually something called a non-standard header file for the GCC compiler. And what it does is that it includes all the standard library, including something like IOString, CMath, algorithm, something like that. That like, if you know C++, then what you would do is that like you'll probably do something like include IOString, and this thing is what like we'll use if you want to use C out. And maybe if you know some other things like algorithm, then if you can use sort. So if you don't add like this header file, you cannot use like this method from that library, something like that. And this thing, we use bits stdc++.h a lot in competitive programming, but it's actually not encouraged to be used when you are developing software or something like that. But here, we're just like, we just want to code fast and then code something that runs fast. So we don't really care about like this because it doesn't really matter to us because like it doesn't affect the time complexity of your code. Yeah. And the next thing is something called using namespace std. And we'll use this line to avoid having to like type out std every time. Or maybe if you know some other things like maybe later we'll talk about something called a policy-based data structure. We will have to type out this namespace if we don't like using it. So if you don't use this line, then for cout or cin or something like that, you have to type std cout instead of just cout. But if you add this line, you can just type cout. So this is also another thing that like we do a lot in competitive programming, but like maybe in actual like software development, you will not add this line. Yeah. So for today, what are the important data structures that we'll talk about that's built in STL? So these are the data structures that we'll talk about today. So the first thing is the static array, which everyone probably already know from Java or maybe other language. So you can initialize a static array in C++ by typing out like the type and then the array name. And then here you can put the length of the array. And then there's also a method to like initialize an array in C++, which is just using this array and then out the type and then the length of the array. And then these two are both what we call a static array, which means that you cannot modify the size of this array. And then if you initialize an array, then if there's something called a local variable and global variable. So if you declare your array locally, for example, you just put it in maybe main function or maybe in some other functions, then it would be pre-filled with random numbers. So if you want it to be like filled with zeros or something like that, then what you can do is that what I mean is that if you declare an array here, then everything here will be some random numbers, maybe 1, 2, 3, and 100, something like that. Dot dot dot. It will not be initialized. So if you want it to be initialized, you can put it outside of this function, and it will become global. So everything here will become 0, 0, 0, 0, 0. Yeah. So that's it. And the second way is that you can just use the for loop to go through the whole array and then set everything to 0, which is just the simple method. And the third way is that you can use an initializer list, which is a special feature in C++, which you can just do something like that. Or maybe if you look at my code, I will do something like this. And this way, it also just set it to 0, 0, 0, 0, 0. Yeah. And the fourth way is that you can just use a built-in function, such as fill or maybe memset, and you can search those functions up on your own. And then for fill, here we'll type out the begin and the end of the, um, you can call it pointer or maybe iterator, but like we'll also not talk about it too much in this video, and you can just look it up. Okay, let's talk about the next thing that we use a lot in C++, which is vectors. So, in contrast to a static array where you cannot modify the size, there's something called a dynamic array, which you can actually modify its size. So how it works is that you can have something called a vector int and something like that. And this thing is a empty vector, which is like an empty array. And then the special thing about this data structure is that you can push back to the vector. So like if you do something like this, then the vector will be filled with 1 to 10. And then each of this operation, this pushback, it is called O1. Instead of if you use a static array and you want to just start a new array of size 2, size 3, size 4, then that thing will cost you O of n. But like if you use a vector, this thing only costs you O1 per operation. And then using vectors, you can also create a variable length array, which is also like what you can do for a static array. But like you just type it like that, then you can declare a vector of size 5, and then you can resize it, which is, yeah. And then if you do this thing, um, the things that if you resize a vector of length 8 to 7, then it will just delete the last element. But if you resize maybe 6 to 7, then it would add 0 back there. And then if you just type something like this, then it will automatically be filled with zeros. So like you don't have to like worry about you didn't initialize it or something like that. And another special thing is that you can have an array of arrays, array of vectors, a vector of arrays, or vector of vectors. And something like this, array of array is actually just 2D array. And then array of vectors is just like a vector of array, which is like, for example, if you go to graph theory, and then when we get to graph theory, maybe if you look at my code, I'll use this expression a lot, which is like we will declare an adjacency list which is like just an array of vectors. Yeah. And then we'll talk about it later, so you don't worry about it. And then, yeah, and this thing is very similar to array listing from Java. So I think everyone here learned Java, so like you should know like how it is working. Yeah. Okay. So the next thing we'll talk about is something called a iterating through an array. So if you want to go through all the elements in an array, the most simple way is that we can just use a for loop, right? Starting from 0 to the size of the vector, and then just output everything. Then it will just output the 1, 2, 3, or 5. And then you can also use something called a for each loop. So in C++ or Java, you might have seen something like this before, which you can just go through all the elements and then output them. And the next thing is that you can also use something called an iterator to do it. But we'll now talk about what an iterator is here. And actually, this iterator has a type vector and iterator. But if you use auto, which is we can just ignore like typing out that thing because the compiler will just figure out it for us. Yeah. And there are some core operations or maybe some methods that you can apply to a vector or some array or something like that. So the most important thing is probably sort, because if you want to write out sort, you might want to write maybe like bubble sort, merge sort, something like that. And yeah, the time complexity is just like maybe O of n squared or of n log n, something like that. But like if you just use the built-in library function, it's O n log n because they use a special method called intro sort. But like you can just, even if you don't know how sorting algorithm works, it's fine. You just know how to use this method and it will be totally fine. And you can also reverse a vector, which is on. You can also fill a vector, which is also on. And you can use something called a next permutation, which we will also talk about in class, like how you can use this to like solve some problems. And this thing will just find the next lexicographical greater permutation from your vectors. Yeah. Okay. After talking about vectors, let's talk about stack. So stack is a data structure that's very similar to vector, except that you can only push and pop from the end in all one time. And then if you've taken any algorithm or data structure class, you'll learn that stack is a lasting first out data structure. And then here are the code examples that you can look at. So here in this stack, we push back 10, push back 20, and then we pop the back. And then we know that the back is now 10, something like that. And then we will talk about some problems that use stack, and it's actually very important. And we will ignore this thing here because we'll talk about it in class. Okay, the next data structure is queue. And then you also probably learned this in data structure class or something like that. And then this thing is very similar to stack actually. So instead of only pushing to end and pop from the end, you can only now like push to the end and then pop from the front. And yeah, it is queue, similar to like you are just in a queue and then yeah, doing some stuff. Yeah. And everything is O1 for stack and queue. So like that is why it is important. And for queue, um, we will not really talk about too much of its applications like in this week because it's mostly used for something called BFS, which you will see in maybe next class or maybe when we talk about graphs. Okay, the next thing we'll talk about is stack. So this thing is very similar to a vector. It's also a dynamic array which you can just random access, like you can just use it as an array. But now, instead of only pushing and popping from the back, a DAC can push back and push front, pop back and pop front, something like that. And then you can look at a code example if you like. And then, yeah, it is actually pretty cool. And then we also use it a lot when we need to like have double side. And then this thing is also called something called a double-ended queue. And it is why it's called DEQ because DEQUE. Yeah. Okay, the next data structure we'll talk about is strings. So in C++, a string is basically just a vector of characters. Like if you learn about C, then you know that C style string is actually just character array. Then in C++, it's actually just a vector of characters. So basically, you can use any operations that you can do to a vector on a string. But like there are also some other methods that you can use. Like you can find a substring of a string using that method. And then you can also maybe find a string in another string using as defined. But like I don't really use it that much, but like, you can look for more like methods you want when you solve problems online or something like that. But, like, there are a lot, so like when you need them, you can just look it up. Yeah. Okay. The next data structure, maybe not data structure, but like a cool thing that we'll use is something called a pair and also tuple. So like we can create a pair in C++ using like this kind of thing. So like you can just type pair, two different types, and then um, equals to like make pair of something. So like this chords, this includes one and two, and this chords two, this includes three and four, and then you can just type it out using this brackets. And then if you want to access the first element, you just type out chords the first, chords the second, and then you can get the elements. And for tuple, it's very similar. You also just type out the three different types, or maybe four different types. You can type out like how many numbers, like you can just type it out, and then you can just make a tuple. And then I think you can also use brackets if you want. And you can get the first thing by using get one, the second by using get two, something like that. But this kind of way is kind of weird, so like I don't use it that much. Yeah. So the example that we will use pairs is that maybe now you want to sort endpoints, and those points are 2D, and then you want to sort the points by the x coordinate and then by the y coordinate. So how can we do this? So if you only have like some arrays that's like stored ends, then it's actually kind of hard to do this because if you have two arrays, one stores x coordinate and the other stores y coordinate, and you want to sort them, you maybe it's kind of hard to like just sort it with the library function because like you have to modify two arrays at the same time. But if you now use a vector pair indent, which is a vector of pairs to store the points, then you can just call this sort on this vector, and then it will automatically sort them by the first and by second. So for pair, if you just use like comparisons, then it will just compare the first and then compare the second. That's like basically how it works. But for pairs and tuples, it is sometimes like unreadable because in your code you will see a lot of something the first, something the second, something get something, and then it will kind of be weird to like read your code. So like another way to fix this is that you can just use structures from C or C++. So, for example, in graph, maybe you'll use something like edge, and then the edge consists of the starting node, the ending node, and then the weight. So maybe I'll just let it be UVW. So for example, here I have a edge 1, 2, 3, and then I want to store its UVW. Then I can just struct this edge. And then when I need to access this elements, I can just the U, the V, the W. So this way, it's actually just easier to use than the first, the second, the third, because you can, using this way, you can also know like what meanings are those like numbers mean. Yeah. Okay. The next important thing is upper bound and lower bound. So suppose now that you have a set or map containing an element close to some number k. So for example, if you have something like 1, 2, 3, 4, 5, and you want to find like the first element that is greater or equal to 3, then if you actually just want to write it, you might heard of something called a binary search. But we don't really use that like if we want to do this in C++, because there are some standard library functions to do this for us. And it's not set on map, but like you can also use it on a vector. Yeah. So there are two things. One is called the lower bound, and one is called the lower upper bound. So for the lower bound, it actually returns an iterator to the least element greater or equal to some element k. And for upper bound, it's just strictly greater. And for these two, I will show some examples in class. And then for these twos, you also you have to first sort the whole array or the vector before you can use these, or else it will like be wrong because what they are basically doing is just doing binary search. Yeah. And here are some examples that you can use on the vector. So for the first thing is that you want to find the first element that's greater or equal to 8, then it is 8, right? Because yeah, if you want to find the first element that's greater than 8, and it's 10. And if you want to find like the first element greater or equal to 7 and the index of it, and you see that it's actually 3 because 8 is the index 3. Yeah. Okay. So after talking about like vectors, let's talk about um, binary search tree. So in C++, if you want to use binary search tree, there's something called a set. And there are also two types of sets. One is unordered and one is ordered. Unordered set is actually something called a hash set, similar to like hash sets in Java. So unordered sets take average O1 time for operation, which is just insert and erase. But they are amortized, or they're not amortized, like they are, um, yeah, they are just they use some randomization. So if you use unordered sets, it can actually, in worst case, be orphan. And I will not talk about why. And then if you take some algorithms class or data structure class, then when you learn about hash tables, you might know about why. And then the thing that we use a lot is ordered sets because using ordered sets, you can insert an element in O log n. You can erase an element in O log n. And also you can use lower bound, upper bound because like it will similar to like a sorted vector. A set, you can imagine it to be like a sorted vector. When you insert something, it's still sorted. When you erase something, it's still sorted. And also in competitive programming, we usually hate um, hash tables because if you use something that costs O log n, like a set or a map, it, it usually runs faster than using unloaded set or unloaded map. Although one is O log n and one is O1. But like um, the unloaded things it's O1 amortized, not amortized, but like um, it has some randomization, but like the older things just always does O log n. So like we prefer ordered sets more than unordered. And then here are some examples with sets. So like if you have a set, you insert 1, 2, 3, and erase 1, then you're in wait, I think this code is a bit wrong. And then um I would do you can just look it up like how to use it. Yeah. So let's talk about more about sets. So like for sets, you can add or remove elements and do binary search without the need to sort. So for example, if we have a set and then we insert 1 and 2, and we want to find the first element that's greater or equal to 2, and it's 2. And if you insert 3 and erase 2, now the set has 1 and 3. So now you want to find the first element greater than 2, and it's 3. Yeah, that's basically how it works. And also, for a set, it would not store duplicates. So if you insert like two ones to a set, then there will only be one one inside. So if you want to keep track of duplicates, then you can use something called a multi-set. And it's just like you can insert multiple elements. Like if you insert 1, 1, 2, then there will be 1, 1, and 2. And then if you want to erase just an element, you have to type out like erase, find an element. And the find costs O log n, and then erase costs O1. And then if you use this erase, this costs O log n. Yeah, O log n plus the number of ones. And then if you use something like count, it would not be too good because this count method would cost linear time. And yeah, so you have to be careful about that. Okay, the next thing we'll talk about is something called a map. So it's very similar to a set. There are actually an older map and older maps in C++, and you should probably prefer like using the older version of a map. And then you can use it as an array with non-integer type. So what it means is that like a map has something called a key and value. And the key, for example, in this example, the key is of type string, and then the value is of type int. And you can just store something like maybe I want to store Sam to be the number one. I want to store Dennis to be the number two. Then if you want to iterate through an order map, we can do something like this. Auto P in M, output the first and second. Or maybe we can do something like this. Auto A, B, and M. So what this does is that like it'll just output Dennis 2 and then Sam 1. And then the reason is that like the map will automatically sort all the pairs by the first element, by the key value. Yeah. Okay. So I might be a little bit fast here, but like we will talk about how to use them more in class. Yeah. So the next data structure we are going to talk about is something called the priority queue, which is also a heap if you have taken any algorithms or data structure class. So this data structure supports insertion and deletion of elements with the highest priority in O log n time, which basically just means that like um, you can access the maximum element or the minimum element in O log n time. And you can also insert and delete, which is similar to a set. And also, if in C++, a priority queue of integers by default is actually a max heap. So an example is that like if you have a priority queue and I push 1, 4, 5, 6 inside, then now the top will be 6. And then here if we pop 6, then now the top becomes 5 because 5 is the second maximum element. And then if you want to make a mini heap instead of a max heap, you can do something like this. You can type out like using the container vector, and then this is the comparison function of the priority queue. And then now if we do this, then now we have 1, 4, 5, 6 inside the priority queue, and we pop the minimum element, which is 1. Then now the minimum element is 4, something like that. And we'll talk about this problem in class, so we'll skip it here. And that's basically it for this video. And I hope to see you in class this week. Thank you.